Hi, I'm Elise, the marketing officer. I conduct a survey to understand student preference and will share the result to help us choose the best ticket price.
Hi everyone, I'm Nishan. I'm the operation manager. I'm responsible for planning the booth's ticket prices and volunteers and ensuring everything runs smoothly.
I'm Janish, the finance officer. My job is to manage the budget and ensure our lucky draw booth raises as much as money possible for the charity.
Hi, I'm Zalfa, the differentiation specialist. I'll use differentiation to determine the ticket price that gives maximum profit.
Hi everyone, I'm Arbaz, the integration specialist. I'll explain how integration helps us estimate the plan and the overall revenue for the carnival. Thank you.
Hi everyone, my name is Madhu. I'm the team leader and my responsibility is to guide to this discussion and make sure everyone shares their idea and also to help our team to reach the best decision.
Hello everyone, my name is James, the carnival organizer. I oversee the lucky draw booths and will approve the final ticket price based on our team mathematical analysis.
So good morning everyone. Thank you for attending today's meeting. As you all know, our carnival is only 2 weeks away and the principal has assigned our committee to organize the lucky draw booth to raise the school charity fund. So each member has a different responsibility, so I'd like everyone to contribute actively. Before coming to this meeting, I conduct a short survey among students from different classes. Most students say they enjoy draw lucky games, especially when there are attractive prizes. However, many students also mention that the ticket price will influence whether they participate or not. Some students prefer 8 ringgit because they consider it affordable.
So from a financial point of view, our goal is not only to attract the customers, but also to maximize the money collected for the charity. So since 10 ringgit is more expensive than 8 ringgit, my first impression is that 10 ringgit should generate more money.
Profit is important, but we should also think about the practical side of operating our booth. We need enough money to buy the prizes, print tickets, decorate the booth, and prepare enough materials.
So those are all good points. At the moment, we have two different opinions. One group believes 10 ringgit is better because each ticket gets more money, and the other believes 8 ringgit is better because more students may be willing to buy tickets. So instead of arguing based on opinions, let's analyze the situation mathematically.
To summarize our discussions, we have two ticket price options, 8 ringgit and 10 ringgit. Our committee must decide which ticket price should we recommend to the school. Decisions must be supported by mathematical evidence.
I still think 8 ringgit is a better choice. Students usually have limited pocket money. If the ticket is cheaper, most students may participate.
I agree with Alice. I've helped organize various school events. When prices are too high, students often walk away without buying anything. Participation is just as important as the ticket price.
Invited our mathematics specialist to help us. Zalfa will use differentiation to determine which ticket prices gives us maximum profit, and after that Arbaz will use integration to help us understand how revenue grows over time. Only after hearing their explanation we will make our final decision.
We have identified our problem. Let's begin with our mathematical analysis. So Ms. Zalfa, can you help us to explain that how differentiation helps us to choose between item 8 or item 10? Would you?
Thank you, Mr. Arbaz. Based on the marketing survey and the previous co-carnival data, we modeled the estimated profit using the following function. P of x equals to minus x squared plus 16x plus 120, where P of x is the profit and x is the ticket price. So this equation shows how the profit changes when the ticket price changes. So to find the ticket price that gives the maximum profit, we use differentiation.
Why did we use differentiation instead of simply comparing item 8 and item 10?
That's a good question. Differentiation helps us to identify the point where the profit is highest. So instead of guessing, we can identify the optimal value using mathematics. So first I differentiate the function. P prime will be negative 2x plus 16. Then we'll set the derivative equals to 0. Then we'll get x equals to 8. So this is the critical point where the ticket price will be 8 ringgit.
Why don't we set the derivative equal to 0?
Because at the maximum or minimum point, the slope of the graph is equal to 0. So think of like climbing up a hill. At the very top, you can no longer go up or go down. So for a brief moment, the slope is 0. In the same way, the derivative is equal to 0 to find the point.
But how do we know 8 ringgit gives the maximum profit is not the minimum?
So to confirm that, I use the second derivative where b equals to negative 2. So -2 is negative and less than 0, the graph opens downwards. So a downward graph means that the turning point is the highest point, so 8 ringgit gives the maximum profit.
And the rate of revenue growth is represented by Rx equals to 6x squared plus 4x. So this equation, it tells us that how the sales and ticket price increases. To find the revenue function, let's integrate 6x squared plus 4x dx, which is equals to 6x 2 plus 1 over 2 plus 1 plus 4x 1 plus 1 over 1 plus 1 plus c, which is equals to 6x power 3 over 3 plus 4x squared over 2. So then 2 and 1 after simplification, this would be 2 and 1 of c equals to 2x power 3 plus 2x power 2 plus c. You get it?
Okay, what does this result tell us?
So this is the revenue function. It helps us to basically accumulate revenue over time rather than just seeing the rate of change. So the C is called constant integration. It represents the value of initial revenue, which is before the ticket sales even begin.
The differentiation analysis showed that the profit function reaches its maximum when the ticket price is 8 ringgit. This gives us a mathematical justification for our recommendation instead of relying on assumptions.
So the integration analysis helped us to obtain the revenue function, which allows us to estimate future earnings and plan our fundraising activities more effectively.
Now I can see that mathematics doesn't just solve the equation, it also helps us better business decision for the carnival.
Thank you for watching.